A very brief look at calculus, page 17. Limits using a graph. And I'm going to say that this weird, strange graph is f of x. I know I can't designate any real equation to it because it's sort of all over the place. And instead of using my pen or marker, I'm going to use a pencil for this one. This means here the limit as x approaches -4 from both sides. So -4 is right here. So as x gets closer to -4 from both sides, I call this like a pimple popper. I'm coming from the left and I'm coming from the right. And I'm going to pop that right there at -4. And the value, y value at -4 right before I get to -4 is actually 1. So that answer is 1. Now the limit as x approaches -4 from the left, that's a left-sided limit, or a left-handed limit. I call it a left-sided limit. So as I get closer and closer to -4, approaching it from the left, the negative side, my y value approaches 1 again. Now I'm going to approach -3 from the right. So I'm going to approach -3 on the graph from the right. What y value am I getting closer and closer to? I'm getting closer and closer to the y value of 2. Even though I don't hit it, I get closer and closer to it. The y value approaches 2. Now, this is asking me, what is the y value when x equals 2? They want a coordinate, and the coordinate's going to be -2, 5. So that's going to give me a 5 there. Now, they want to know what the y coordinate is when x equals 0. When x equals 0, the coordinate is 0, 5. Whoa. 0, 5.5. Notice it's a little bit between it. So that's going to give me 5.5 or 5.5. Now the limit as x approaches 1 from the left. As x approaches 1 from the left, I'm following along, and that's going to give me 4. Now my limit as x approaches 1 from the right. As x approaches 1 from the right, that's going to give me a y value of 2. Now the limit as x approaches 1 from both sides, from the left and from the right, notice they do not meet each other like over here. They met. You're just looking across the little hole there saying, hi, I'm over here. Hi, I'm over here. Here they're too far away. So that limit, because they don't meet, is called DNE. The limit does not exist. And you might have heard that from the movie Mean Girls. That's what she meant when the limit did not exist. If she had a graph of it, she'd have seen it instantly and would not have had to have thought about it so much. The limit as x approaches 9 from both sides. Now I know the y value when x equals 9, the coordinate is 9 too, but the limit is 3 because it approaches 3 from both sides. What is the value at 9? Now that's the coordinate, 9, 2. 9, 2. This here is evaluated at 9. This is the limit as it approaches 9. A subtle difference. And this one here has a lot of interpretive question marks. The limit as x approaches 4 from the left and the right. Notice, it goes to positive infinity. It goes to positive infinity. This one went to 2 and this one went to 2. So the limit was 2. Some people will say the limit as this approaches 4, because it's positive infinity on the left and positive infinity on the right, the limit as x approaches 4 is positive infinity. Other people say it doesn't exist. I'm going to go with positive infinity. That's my take on it.